Welcome to Constellations, the podcast from Kratos, where leaders discuss what's coming next in satellites and space.
Welcome to Constellations, the Kratos podcast. My name is John Gilroy. I'll be your moderator today. Our guest today is Rick Lober, Vice President and General Manager, Defense and Intelligence Systems Division of Hughes Network Systems. Rick, how are you?
I'm doing great, John. I'm happy to be here.
I know a little bit about your background. I think a lot of the audience here might not know. Why don't you give us just maybe a 30-second summary of what your background is?
Yeah, I'm an electrical engineer by training, and started out as a design engineer in mostly radio communication products, and then moved up into project engineering, program management, and then P&L management. At Hughes, my group takes the commercial technology that they make and sells it to the DoD and other government users.
Well, this is a very interesting place to be in space and time, because the federal government is getting bombarded with requests to do less, more with less, and you have some commercial solutions that may help them.
Yeah, especially in the communications area. I mean, it's rapidly evolving on the commercial side, and the government needs to keep up. So commercial industry, most of it is working very closely with government to get commercial products that'll bring costs down and capabilities up.
Last time I spoke to you, you told me that your company motto was innovation delivered. It's a pretty bold statement.
Yeah, but it really is. It goes to the core of Hughes. Hughes Network Systems has been around since the mid-'70s. Typical story, starting in a garage in Rockville, Maryland. We invented a lot of what is VSAT today, or at least made it producible in large format. So we've got some very, very deep roots in satellite communications, and have taken that now to bring satellite internet to consumers in unserved areas, enterprises. You use us every day. And government and defense applications.
Well, good, Rick. So you have some innovation there. It's applied real well in the commercial area. I want to talk about the federal government here. So what is the industry doing to help agencies address issues of constrained resources and aging systems?
A lot of things in the communications area. I mean, costs continue to come down and capacity continues to go up. So we try to make sure that the government is seeing those type of products and those type of advances. With that, one of the larger components of government and defense is personnel costs. So we try to improve network management systems such that we can have less people, say, in a room running a large network than what was done, say, 5-10 years ago. Hughes, even though we're a satellite communications company, we also do a lot of terrestrial communications, so smarter ways to get data over fiber and cable. Hot topic there right now is called SD-WAN, software-definable wide area networks that allow you to optimize things in a way which is much more efficient than, say, even 5 years ago.
Yeah, I was on your Twitter feed. I saw hashtag SD-WAN. This morning. Interesting. Let's take a look at this commercial innovation, apply it to the military. What role do you think commercial Satcom will be in evolving new types of military missions and the increasing need for bandwidth?
I think it'll be a key role. We're always going to have military satellites. They're key. They're very specialized. But if you look back 10 years ago at the height of the Iraq-Afghanistan war, about 80% of the bandwidth being used was from commercial companies. So going forward, and that was done almost fairly urgently as the war built up, and I think the DoD probably paid a little bit more than it needed to on some of those short-term leases. Looking forward, we are working closely with the DoD to make commercial part of the answer as a planned program, not something that is done after the fact. So I think you'll see both.
Is this where the hosted payload would fit in?
Yeah, hosted payload. Hughes just did a hosted payload for coverage in Brazil, and we were able to turn that around very, very quickly. So we see the DoD being able to do the same type of thing. Partial leases of satellites, possibly pre-launch type satellites. DoD gets, say, a 20% share for capacity in certain parts of the world. Network interoperability is another thing the industry is working closely on to make sure various commercial networks will talk together along with DoD networks.
I meet military people all the time. I go to events, and I bet you've heard this, and I've heard this from people. They say that they can get better connectivity on commercial airlines right now than what you're getting on some military planes. Sounds like an opportunity for Hughes.
Yeah, that's true. I mean, we were one of the first to do it on commercial airlines with Southwest Airlines, and we're continuing to expand that. We'd like to offer the military the same thing with a worldwide network and equipment that's a little bit lower cost than what they're using. But it's important to keep particularly troops en route to a mission, connected 24/7, because the situation may be very different when they land 6 or 8 hours after they took off.
I've heard all kinds of acronyms when I deal with the federal government, and in information technology there's an acronym called DR, disaster recovery. But I think the real DR is for hurricanes. I think that's where organizations and businesses like yours can help respond to real disasters with people getting flooded out of homes.
Yeah, and we have been. We've just shipped, I think, over 100 terminals to Puerto Rico for charitable relief. We're working with FEMA and DHS in Puerto Rico, and satellite's a great technology for that, because you can set up a relatively small earth station, if you will. It's a 1-meter antenna and a small box that goes with it, and pick up right from the sky, where cellular infrastructure takes a while to rebuild. Even underground fiber and cable can get flooded out or dug up. So satellite's usually the first place you go for disaster recovery.
Well, the first place I went when I heard about the Puerto Rico disaster, I went to Google Trends and typed in satellites, and Puerto Rico is like the third search term found there. So there's a lot of association with disaster recovery and satellite and all kinds of innovation there. One innovation is High Throughput Satellites, HTS. How is the government and military taking advantage of new HTS services and bandwidth to support these missions?
The government right now primarily uses a satellite they call WGS, Wideband Global Satellite. They're looking at how they're going to replace that in the future, because satellites typically only last about 15 years. As part of that, they've done quite a few funded studies with companies like Hughes, RT Logic, Intelsat, others that make or support HTS satellites. So they're taking a hard look at it, and we're seeing about a 10 times capacity increase in these generations of HTS satellites.
When I think of satellite technology, I think of a dish and a satellite and maybe more stationary, but in some military applications, you have to be moving all the time, possibly on the water, and the ground, mountains, humans, individuals. So comms on the move that fits in with some of the products you have, doesn't it?
Yeah, comms on the move is a lot of what we do, both ground and airborne. Airborne, usually it's getting data down to the ground, video data, other data that might be collected for surveillance. Vehicular can be, right on the battlefield. So we're really trying to push communications to the forward edge. There's a little bit of a two-edged sword there if you've been following on what's going on with some of the large Army systems in terms of trying to keep complexity at a minimum for these newer, more capable systems.
When I sat down with you the last time, you talked about Hughes, and I wrote down another phrase is innovation is doing the right thing for our customers. And so what you're trying to do is you're trying to listen to your customers and see what kind of successful commercial technology will apply in many different military situations. Is that right? Right.
Smaller, lighter, lower cost. The military has a particularly tough task and burden, and that oftentimes soldiers are carrying this equipment into the field. So we try to innovate with technologies that will allow for smaller equipment size, smaller antenna size. Antennas become targets, so you want those as small as possible. That's where some of the innovation that Hughes has generated over the years is being applied to the DoD.
Up the road here in Arlington, there's a trade association. There's about 1,000 in Arlington, and it's for UAVs. And they talk about all kinds of innovations with bandwidth, resiliency, security. Where's your company fit in with that product?
Yeah, as I said, we started with some airborne communications in Southwest Airlines, and then took that to large UAV manufacturer General Atomics. Just selected us recently to upgrade their satellite communications on their UAVs, and we're going to bring them a product that is smaller, more efficient, and lower cost. So it's been a good start.
Earlier I mentioned Wi-Fi on a plane. Now, if I'm sitting on a plane watching a movie on my phone, I'm absorbing a lot of data. However, a UAV is probably doing the opposite. It's vacuuming in a lot of data. So you have two applications that seem like it's just satellites, John, but this is two different types of communication, isn't it?
The architecture is flipped, which was a little bit problematic at first using commercial technology, because we're primarily trying to get data into the plane, where a UAV you're trying to get data out.
Yeah.
But we've solved that, and commercially we just demonstrated 50 megabits per second into the plane, where in the past that was probably closer to 10. UAVs, we're doing typically about 50 megabits per second out of the plane, which will give you HD video fairly easily. Well,
we went down to Arlington. Now we're going to go to downtown D.C. There's a company that's based there. It's called Measure, and they're called a drone as a service company. And they work with architects and construction people and safety inspectors to inspect towers. And it looks like there's all kinds of new environments, new applications for UAVs, aren't there?
Yeah, quite a few. The larger UAVs that we're working with are used already for firefighting. They were just used in the California fires. They're used for agriculture, obviously search and rescue. The smaller ones, you've got Amazon talking about delivery by small drones, as the industry sometimes calls them. So I think you're going to see a proliferation of commercial uses, particularly when the larger UAVs are allowed to fly in commercial airspace, which is coming soon.
I had a little silly topic about UAVs and watching movies in a plane, but there's some serious things going on with the military here, and they can't afford to have a system fail. I mean, if I'm on a plane and I can't see my movie, well, no big deal. But if there's a military situation, they got to have a reliable signal. It's got to be resilient, doesn't it?
Yeah, resiliency is pretty key, because sometimes in a UAV somebody may be giving a command to fire some type of a weapon, so you don't want to see a blink or a loss of a video signal. We work hard to ensure that with some of our technology. And then resiliency in the bigger case is just making sure Satcom is there through a variety of means, whether it be military or commercial.
When I went to your Twitter feed this morning, I saw the hashtag SDWAN. I also saw the hashtag resilience. So it must be something important. Must be something part of the DNA in Hughes.
Yeah, resilience is important. I think for everybody. You get a lot of false impressions out there that maybe I've got two providers for my telecom service to my building, but they may be going over the same fiber cable that can be cut, or you're the military and you're using a single satellite. So commercial industry, there are hundreds of satellites up there, and with these low Earth constellations, you're talking about maybe thousands of satellites in a constellation. That gives you plenty of resiliency or choices.
If you're technically adept to be able to switch off between satellites and between systems, give that resilience, that's the tough part. So what developments are taking place in the aero and mobility environment to deliver this connectivity on demand anywhere?
Well, I think commercially you're going to see just about every airline, every airplane out there having internet over satellite. They tried it from the ground, but that doesn't work so well when you're over the ocean. There's no cell sites. So we're rolling out a new product for the commercial airlines that will give worldwide connectivity, and we see that being able to be applied to the military also. So whether it's troops or leadership flying around, we can give them connectivity while they're en route to a mission.
What about something as large as an aircraft carrier? I mean, they're going to demand some higher speed connectivity, and that's a flexible environment, isn't it?
Yeah, I think the aircraft carriers, you've got about 5,000 people there. Right now, they're typically getting about 25 megabits per second into a carrier, which is about what we do into a home now for the consumer.
Isn't that amazing? Think of that.
It's a little bit more challenging in the middle of the ocean, but I feel they're going to need a lot more. Even just the maintenance of some of these new platforms and the software downloads and updates that you may want to do, and the amount of bandwidth that will take, in addition to everything else you're trying to do.
There's so many innovations in the area of satellites and new space and all kinds of things. So looking at 4 or 5 years down the road, maybe 5 years down the road, what kind of advancements do you see taking place in supporting the military and intelligence in the area of communications?
Well, I think the LEO constellations are going to play a important role. LEO means low Earth orbiting. You can actually see these things in the night sky. They look like moving stars. We're working with a company called OneWeb that is going to launch about 800 LEO satellites to serve unserved parts of the world, and we see military application for those type satellites due to the resiliency and the overall capacity of that type of network.
My. I can remember when it was front page news, just one satellite. Now, you just tossed that word out there. Well, 800. I mean, think about that number. I mean, it seems common to you, but I'm sure if you just walked down the street and told someone that 800, that's a big number. That's a difficult number to just coordinate and structure.
Yeah. I mean, they are setting up a manufacturing facility down in Florida, and expect to, crank these out in a production line type environment. Bringing the satellite simplicity down quite a bit for some of these LEO constellations.
Do you folks have a facility that you manufacture product here in the Washington, D.C. area?
Yeah, we do. And Washington, is not the lowest cost place to manufacture, but right here in Rockville, we have a factory does about $40,000 a month. And all robotic assembly. It's fascinating to watch. Very, very high frequency, RF electronics being manufactured at that rate, and that primarily drives our consumer business.
I teach at Georgetown. They have whole 15-week classes on enterprise architecture, EA. And so when I hear about satellite system architecture, I wonder, it's got to be more complex in some of these large systems. So when it comes to future satellite system architecture, just toss in 800 more satellites. Nope. It just seems like this is going to be a whole separate world just managing this.
Yeah, network management is really going to be a key aspect of all of this, and that's one of the things that I think we've done well and built up over the years, and probably is the lowest hanging fruit, in my opinion, for the military. A little bit of network management goes a long way in terms of efficiency of the satellites that you have, and it's going to be a must for these higher order constellations as we go forward.
I read an interview you did with a local magazine called Executive Business, and you talked about having the government and the military adopt Satcom tools from the commercial area. You talked about the financial resources and bandwidth. So what kind of tools in the financial area do you think might apply for the military folks?
Well, we've developed a lot in terms of billing systems, that type of thing. I think there's application to the military there. I mean, it's all one government, but they can figure out how much various branches are using and to allocate it properly. Repairs and problems. We have a active network management facility right now that is looking at over 1 million users, and we can see exactly what each terminal is doing and what the problems may be. So those type of technologies and processes can be applied to the military network also. The
government space architecture, how's it been received?
Very well. Right now, it's good to see the military engaging commercial industry on some funded studies on how they could use this technology, how these technologies can interoperate with military and other commercial networks. So I think the message is starting to get across that there's an important role for commercial going forward.
I think if you just did a survey of 100 random people, they would think that satellites, they're in outer space. they're safe out there. The's nothing there. Nothing can possibly go wrong out there. I mean, what do you worry? It's like being in the middle of the ocean. But I think what's happening is that there's more and more challenges, even in the area of maintaining the advantage in space and protecting the hardware that's up there.
Yeah, it's certainly changed. I mean, in the past, it was typically a failure. Typical life is 15 years. You may get a failure, but that's pretty rare. You may get some space debris. That's pretty rare. But there's a lot more concern now in terms of keeping these satellites going if we get into a larger conflict. So hence the need for resiliency. If you've got 800 of them up there, it's tough to take them all out. There's also other ideas being bandied around. Balloons. I think Google's got balloons right now over Puerto Rico doing communications. So
sounds like the 1920s, doesn't it? I mean, balloons. Come on, Rick. Come up with something more modern than that.
Yeah. You move away from a satellite if you need to. UAVs are used for communication relay, so they're kind of like satellites, but they're much lower orbit. But I think the key will be the LEO constellations and the increasing use of HTS satellites will give us what we need.
A little inside baseball here for some of our listeners. Hughes announced this summer that it was awarded a Wideband Communications Architecture Study, WCAS, to support the DoD for resilient, cost-effective satellites. Do you think this is going to go forward, and what kind of conclusions do you think it's going to reach?
Yeah, we're just finishing it right now, and it looks like there's going to be follow-on studies. This is what I had mentioned earlier about the DoD engaging commercial industry actively and as part of the plan going forward for their military communications over the next 5 years. So we're pretty excited to participate and feel we have a lot to offer.
I don't know much about satellite application in the commercial FEMA, any of those applications there. I imagine NASA's obvious, but there's some other commercial agencies as well, huh?
Yeah, this has primarily been funded right out of the DoD for their applications, but it applies to other agencies. The agency we call DISA, Defense Information Systems Organization, helps support not only DoD but other organizations, and they are also participating in a fairly big way in these studies for future communications.
I've talked to several people from DISA, and many times they have the better mousetrap, but they can't buy the better mousetrap. In other words, the challenges in the acquisition process itself, and it seems like that this study may conclude something and then get bottlenecked into something that you have no control over, the acquisition process.
Yeah, there's two legs to this study, which has been interesting. One is the technology and the system engineering approach, and the other, they call these pathfinders, are studies in different acquisition means. Can we lease longer than a year? How can we buy more quickly? But I think you've hit the key in that military acquisition of communication systems has got to be a little bit different than, say, buying an aircraft carrier.
Yeah. Some people in the Air Force are talking about this concept of an OTA, and that may add some flexibility to the whole idea of just buying new things.
The OTA, or other transaction authority, is a way that the DoD can engage commercial companies a little bit more quickly than a typical DoD acquisition process.
Yeah, I spoke with Chairman Gorgonpour about this. The guy's got a PhD. He's a really smart guy. And he said, look, this is the best way to do it, because an acquisition process that takes 2 years, by the time you complete the acquisition, the technology, especially with something like Hughes, is going to change twice. And so how do you maintain that flexibility? Same thing you're doing with the satellites. This has to be solid but flexible. It's got to be secure but flexible. It's almost the same challenge. It's almost parallel there.
Yeah, communications, we pretty much respin our systems about every 2 years. There's a major technology refresh, and the actual acquisition time in the DoD for what they call a program of record is probably closer to 5 to 7 years. So for communications technology, that's problematic, and they've got to figure out a way to turn this crank a lot quicker.
Well, Rick, unfortunately, we are running out of time here. Our guest today is Rick Lober, Vice President and General Manager, Defense and Intelligence Systems Division of Hughes Network Systems. Thank you very much, Rick.
Well, thank you, John, and thanks to Kratos. I enjoyed participating.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.